we're going to take a look at the cofunction identities for the sine and cosine functions. That's what these are right here. Sine of pi over 2 minus theta is equal to cosine of theta, and cosine of pi over 2 minus theta is equal to sine of theta. Now there are actually other cofunction identities using the other trigonometric functions, but they all have the same basic shape, and they're all proven by the same basic method we're going to have here. So we'll just keep our focus on the sine and cosine functions. So there are a couple of things we need to think about as we get started. The first one is, what is this angle pi over 2 minus theta, and how does this fit in with theta? So if we have a right triangle like this, we're going to label this other angle over here alpha. And what we need to think about is, what is the relationship between alpha and theta? Well, we know that the sum of the angles in the triangle all add up to 180 degrees. Now we're going to do everything in radians because it's good practice. So all the angles add up to pi radians. So theta plus alpha plus this right angle, a right angle is pi over 2, is equal to pi. Again, all in radians. Let's rearrange this. Let's subtract off the pi over 2 from both sides. Theta plus alpha is equal to pi over 2. Now remember, pi over 2 is 90 degrees, and you might remember that there's a word associated with two angles that add up to 90 degrees, add up to a right angle. These are known as complementary angles. And so this formula right here tells us that theta and alpha are complementary angles. But we can go one step further, and we can solve for alpha. Alpha is equal to pi over 2 minus theta. And this right here is what appears up here. So what's happening with this formula is that it's saying that the sine and cosine functions on the different acute angles within a right triangle are related to each other. And now we just need to figure out why. Why is this the thing that works? So I'm going to start labeling the sides. So relative to theta, this is the hypotenuse, that's the adjacent side, and that's the opposite side. But remember that the labels change depending on whether you're looking at it relative to this angle or that angle. So let's take a look here. So relative to this side, well, hypotenuse will always be the same. This over here is the opposite relative to alpha, and this is the adjacent relative to alpha. And so let's take a look at the first one. Sine of pi over 2 minus theta. Okay, sine of pi over 2 minus theta. That one's the alpha. Sine of alpha. Sine of alpha, sine SOHCAHTOA, sine is opposite over hypotenuse. So the red opposite over the hypotenuse for this left-hand side here. Right-hand side, cosine of theta. Cosine is adjacent over hypotenuse. So relative to theta, we have adjacent over hypotenuse. And what we can see is that even though the names are different, the thing that they refer to, the actual part of the triangle that they refer to, is the same. The red opposite and the green adjacent are the same side. They have the same length, and the hypotenuse is always the hypotenuse. And so what this is saying here is that the sine of the other angle in the right triangle is the cosine of this angle. So there's this sort of interchange between the two functions. So anyway, these are the cofunction identities. You can do the same thing with the cosine of the sine. You'll just see that instead of here, you'll have adjacent over hypotenuse and opposite over hypotenuse in the appropriate colors. And so this shows us how these cofunction identities work and why they are what they are.